Good afternoon, class. We are looking at exam 2 review, covering chapter 3, differentiation rules from 3.1 to 3.8. And here's the second part, section 3.4. The chain rule. All right, we're going to continue looking at more examples. In this case, we want to find an equation of a tangent line to the graph of the function y equals e to the power of x times cosine x at 0, 1. We remember that this is the product of e to the power of x and cosine x. We put a raised dot in between and we call it f times g, meaning we are using the product. So having said that, we are going to follow the shorthand notation. Fg prime is f prime g plus g prime f. So f prime is e to the power of x itself times g, which is cosine x, plus g prime, the derivative of cosine. The derivative of cosine is negative sine x times f. The f function is e to the power of x. And we're going to factor the e to the power of x out. We get e to the power of x times cosine x minus x. That's y prime. What is the slope of a tangent line? We plug in the x equals 0. So m is y prime of 0. In other words, it's e to the power of 0 times cosine of 0 minus sine of 0. Obviously, this is 1, this is 1, so the answer is, and sine of 0 is 0. So the answer is 1. Because this is the y-intercept, in other words, b equals 1, just use y equals mx plus b and replace it, and y equals x plus 1. You don't have to use the point slope. We are done. The equation of a tangent line is y equals x plus 1. Y equals cosine x over 1 minus sine x. We are going to write this as f over g, and we are going to use the quotient rule. Shorthand notation, f prime g minus g prime f over g squared. So y prime starts with f prime, the derivative of the top. Cosine is negative sine x, times g, 1 minus sine x, minus the derivative g prime. So the derivative of 1 is 0, minus the derivative of sine is cosine x. So because of this negative, we have minus cosine x. So minus cosine x times the top. The f function is cosine x also. Let's distribute. This is minus sine x. This is plus sine squared x, minus plus cosine squared x. And by the way, over the bottom, g squared, 1 minus sine x, quantity squared. So we just repeat the bottom and distribute the top, and we notice sine squared and cosine squared, they add up to 1. So the numerator is 1 minus sine x. The denominator is the same thing squared. Therefore, we can drop this and the exponent changes to 1. So the numerator, 1 minus sine x, goes away and becomes 1. And the denominator becomes 1 minus sine x only, not to the second power. I hope it makes perfect sense to everybody. And now the new stuff, the chain rule. I wanted to remind you of what we have covered actually. How would you differentiate composite functions? For example, y equals square root of 10x plus 5, or f of x equals 10x squared minus 1 to the power of 50. Well, we use the chain rule. So what's the chain rule? If g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. d dx of f of g of x is f prime of g of x times g prime of x. I want to make sure everybody understands what's happening here. F of g of x. F is the shell function, the outer function, the main function. G is the inner function. So you differentiate the shell function over the inner function g of x times the derivative of the inner function. This is the part which in essence is known as the chain rule. And as far as Leibniz is concerned, if y is f of u, that means u is the independent variable for the function f. And u is g of x, that means x is the independent variable for the function u. Then he would go with dy dx is dy du times du dx. If you treat this as two fractions, you can cancel out the du, which is not the case. So, to repeat the concept, capital F represents f of g or f of g of x. Capital F prime represents the derivative of that. And that would be f prime of g of x times g prime of x. That's the inner function. Now, one interesting example would be if we go to extended power rule. Starting with the regular basic power rule, we know the derivative of x to the power of n is n x to the power of n minus 1. But what if we have, instead of x, g of x, some function of x, and we want to raise it to the power of n? So according to this, if we get started, we start with n, then x to the power of n minus 1 becomes g of x to the power of n minus 1. Furthermore, notice the derivative of x is 1. So if we don't write it, it makes no difference. But now, according to the chain rule, we need the derivative of g of x, which is no longer 1, but rather g prime of x. This is known as the extended or the general power. This set of examples would make this, I believe, easier to understand. So y equals sine 2x. The way I approach trigonometric functions in general, I'm going to underline the function of interest. In this case, is sine. And I'm going to say y prime. For sine, I need cosine. But if you have any trigonometric function, it's meaningless without an argument. So you must have the same argument on the one hand. On the other hand, this is not x, it's a function of x. So the chain rule applies. You need the derivative of 2x, which is 2, and you rewrite it as 2 cosine 2x. Same thing here. I'm going to underline sine x, and I'm going to say the answer must be cosine. But cosine is meaningless without some sort of an argument. So we have to use the same argument. By the chain rule times its derivative 2x, we rewrite it as y prime equals 2x cosine of x squared. What about the next one, y equals sine squared? First, I want you to notice it means sine x to the second power. So we are using the extended power rule. 2 sine x to the power of 1, the derivative of that is cosine x. So 2 sine x cosine x. I hope This helps with the concept and how the chain rule works. Let's look at a warm-up example where y is a function of u to the power of 5, and u is a function of x10 x cubed plus 2, or g of x. And we want to differentiate it, and we want to differentiate it two ways. We're going to go with the Leibniz's notation, dy, du, dx first. So dy du means, okay, take the derivative of this with respect to u, and it's a simple case of a power rule, 5u to the power 4. Now du dx, take the derivative of this function with respect to x, which is simply 30x squared. Very simple. So the product of the two is 5 times u. U is 10x cubed plus 2 to the power of 4, and times 30x squared. You put that in front, and it becomes 150x squared times 10x cubed plus 2 to the power of 4. And we are done. However, this is easy to find the composite function. So f of g means f of g of x, or 10x cubed plus 2, which means right here, replace the u with 10x cubed plus 2 and raise it to power 5. And so if you want to go with the derivative, you go f prime of g of x times g prime of x. So we are going to differentiate this using the chain rule, or in essence, the extended power rule. We start with 5, so we call it dy dx of y prime plus 5. Then the same thing to the power of 4, right? And then the derivative of the inside, this is by the chain rule, which is 30x squared. And we rewrite it by putting this in front. We get exactly the same answer, 150x squared times 10x cubed plus 2 to the power 4. Bear in mind, we learned both methods because sometimes finding the composite function is either very difficult, or differentiation is easier to use the Leibniz's notation rather than using the composite function. All right, y cos 10x squared minus 1 to the power of 50. We want to differentiate this. And clearly, we can use the extended power rule. So you write the formulas from memory, and you start working on it. So y prime starts with 50. Then the function g of x to the power of n minus 1, this thing to the power of 49. And g prime, the derivative of the inside, which is 20x. And now we put this in front, and we end up with 1000x times 10x squared minus 1 to the power of 49. All right. What about y cos squared of 10x plus 5? We use our algebraic techniques to get it ready for the power rule, or more specifically, extended power rule. So it's 10x plus 5 to the power of 1/2. And so n, the answer y prime or dy dx is n, which is 1/2. G of x to the power of n minus 1, the same thing to the power of negative 1/2, because you're going to subtract 1. And then times the derivative of the inside, g prime, the derivative of the inside, this is the chain rule, and becomes 10. And obviously, you have a fraction bar. The top is 10, the bottom is 2, so they simplify to 5. And this one, to the power of negative 1/2, goes down, becomes positive 1/2, and a square root. So it's important to use your algebraic techniques to rewrite this properly, everybody. What about y equals 5 times 3x minus 2 to the power 4? First of all, we just write the 5, y prime equals 5, so that doesn't change. Then n is 4. Then the same function, the parentheses, to the power of 4 minus 1, because you're going to subtract 1. And now by the chain rule, the derivative of the inside, which is 3. That's, of course, the end of the story as far as calculus is concerned. And you put 5 and 4 and 3 together, becomes 60. So 60 times 3x minus 2, quantity cubed, and that's the answer. We want to take the derivative of e to the power of 10x. The derivative of e to the power of x is itself, and the derivative of f of g of x, f prime of g of x times g prime of x, that's the chain rule. Therefore, if the exponent is not x, but rather a function of x by the chain rule, you write the same function e to the power of x times g prime of x. G prime is the derivative of the exponent. If it happened to be e to the power of kx, then it's itself times k. The way I approach this stuff, any exponential, I start writing the function itself. Then I look at the exponent and say, okay, the chain rule says I need 10. I put it in front. I rewrite it, I'm done. What about this one? Same thing. I'm going to write the function itself because it's an exponential. That's how I start. And I say, okay, the exponent is not t, but rather a function of that. So I need the derivative of t squared, which is 2t, and I come up with the answer. By the way, some students who have learned the differentiation before, they write d dx of this, d dx of that, or d dt of this. I think if you write the formula and follow it, that's the best and easiest way to come up with the answer. Now, for this one, first I'm going to write it as e to the power of 2t. Then y prime is itself e to the power of 2t. Now, the derivative of 2t is just 2, and I rewrite it, and we are done. Well, y equals e to the power of 2x over 3. First, I want to rewrite this one as 2/3 x in case. Not that you have to. I want to make sure that we can see what we are dealing with, and therefore I'm going to write y prime is itself e to the power of 2/3 x first. Then I need the derivative of 2/3 x, which is simply 2/3. I put it in front, and the final answer becomes y prime equals 2/3 e to the power of 2x thirds. So that's pretty straightforward. Y equals 5x times 3x minus 2 to the power of 4. We want to differentiate. What I want to mention here is number 5. If this number is involved, meaning it's large, for example, 10,000, or very small, like a fraction or a decimal, 2/3 or 0.158, you really want to put brackets here and separate them. But at this point, it doesn't make any difference. I'll show you both ways. So I'm going to notice that it's the product of 5x and 3x minus 2 to the power of 4. So that means I need the power rule. So I'm going to write the product rule first. So FG. So I'm going to put a raised dot in between. I'm going to call it FG. And I'm going to use first the product rule. And of course, in conjunction with the chain rule. So the derivative of 5x is just 5 times g, which is 3x minus to the power of 4. So far, fairly basic. Now, plus g prime. The derivative of this piece uses the extended power rule n, so plus 4, 3x minus 2 cubed, and then the derivative of the inside is 3, and then times f, 5x. In other words, we have f prime g plus g prime f. And I'm going to put an asterisk next to it, meaning I'm done with calculus. However, I have several steps to finish the job algebraically. So to make it easier to see what's happening, this doesn't change. 4 times 3 times 5 is 60. So I'm going to put 60x first. So it becomes clear that 5 is in common. So it's 3x minus 2, but which exponent, 4 or 3? Obviously, we go with the smaller of the two. This is simple factoring. Everybody should be very comfortable with that. So if I divide this one by this one, I end up with 3x minus 2 here. And if I divide the second piece by it, 60x divided by 5 gives me 12x. So this remains the brackets. We can simplify it to 3 and 12, 15x minus 2. So y prime, the final answer would be equal to 5 times 3x minus 2 cubed times 15x minus 2. This is the final answer. The second method, and as I mentioned, if this number is involved, is to do the following. You put brackets here. Okay. So now 5, you just keep it outside, and we want to go with f prime g plus g prime f again. But this time, see, the derivative of 5x was 5, but now you're dealing with x. So you put the 5 outside the brackets and say the derivative of x is 1. 1, so instead of 5, 1 times this one. And for this piece, it doesn't change. This piece, 5x, the derivative, the f is not 5x, is x. So please understand why we change it to x. So as you notice, 5 remains outside, and it carries over as a factor. Now, again, doesn't make much of a difference here, but it will. If this number is involved, you don't want to keep on carrying it, okay? So just take it out as a factor and deal with it as such. What about x squared plus 4x over x to the power of 6? If you want to differentiate any rational function, the very first question is, can I simplify before you move on? Notice two fractions. The first one gives you x, the second one gives you 4, and now you are going to use the extended power rule. So 6, same thing, x plus 4 to the power of 5. And then the derivative of the inside, although it's 1, I recommend you write that because it's a parenthesis. And you rewrite it and you're done. What about this one? Again, a rational expression, can I simplify? That's the question. Please understand, if we are supposed to simplify it, that means it must have a factor of x plus plus 3. Otherwise, it can't be simplified. So try, if I were you, I would try with the same factor, see if it works. Well, because this is 2x squared, I have to go with 2x. Because this is 9, if I divide it by 3, I get positive 3. Do I get the middle term? Take a look. We are going, let me use a different color. We are going to look at the middle term. Before I look at the middle term, let me explain this because this is important. Understand x times 2x is 2x squared. 3 times 3 is 9. That's not a problem. So that's why you want to make sure the middle term works, meaning I'm going to multiply these two, I get 3x. I'm going to multiply these two, I get 6x. And do they add up to 9x? They do. So I'm going to simplify. And now, of course, the answer is simply y prime equals 2, and I'm done. Y equals 2x plus 3 over x minus 8 to the power of 5. Again, the first question is, can I simplify? The answer is no. Therefore, we're going to go first and foremost with the extended power rule. So 5. What's inside the parentheses to the power of 4? And now the derivative of the inside requires a quotient rule. So it's a combination of a chain rule and a quotient rule. The derivative of the top is 2 times the bottom x minus 8 minus the derivative of the bottom is just 1 times 2x plus 3, the numerator, and then you put the denominator and square it, x minus 8 squared. And this is the extent of calculus. Now, a couple of steps to finish the job, and you must finish the job. This is not acceptable as the final answer. You use your algebraic technique. So first you want to distribute 2x minus 16 minus 2x minus 3. And 2x and minus 2x cancel each other. Minus 16 and minus 3, they add up to negative 90. Now you can go to the final step, but to make sure we're not going to make a mistake, this one is fine. This one, you write it as 2x plus 3 to the power of 4, x minus 8 to the power of 4. And of course, the last one, you just write it. The reason I wrote that, because I want everybody to see the denominator has x minus 8 to the power of 4 plus 2, which is 6. The numerator is 5 times negative 19, which is negative 95, times 2x plus 3 to the power of 4. Now, if you don't need to write this step, you can go to the last one. That's just as good. It's your choice. As long as you don't make a mistake, all is fine. What about y equals 4 over square root of x squared plus 3? Anytime you want to differentiate a function where the numerator is a number, you don't have to use the quotient rule. By the way, don't avoid the quotient rule. If you have to use it, you have to use it. So this is x squared plus 3 to the power of 1/2, right? Square root of x is x to the power of 1/2. And then bring it up using negative exponential rule. If you have a negative exponent, take it down, make it positive. From the bottom, bring it up. So we make it 4 times x squared plus 3 to the power of negative 1/2. This is a simple algebraic step, everybody. To differentiate this, y prime starts with number 4. Now we're going to use the extended power rule on that. Negative 1/2 times same thing to the power of, subtract 1, negative 3/2, times the derivative of the inside. That's why it's called the chain rule or the extended power rule. Now the derivative of the inside, 2x. This makes it a chain rule, and we are done with calculus. Now, let's rewrite this to make sure it's easily understood. 4 times negative 1/2, negative 2 times 2, negative 4x. And we just repeat this. We take this down, make it to the power of 3, positive 3/2. Again, we are using the negative exponential rules. You can't represent it with negative. And then we take it to the same format, the root format. It becomes minus 4x over the square root of x squared plus 3 quantity cubed. I hope nobody has any problem with the algebraic steps mentioned. Y equals cosine of 3t to the power of 4. First, let me explain a couple of things. Number one, we know the derivative of sine is cosine x. Therefore, the derivative of sine u is cosine u du dx. U is a function of x. And the derivative of sine of g of x is cosine of g of x times g prime of x. This is, or du dx, by the chain rule. Same thing for cosine. The derivative of cosine is negative sine, and the derivative of cosine u is negative sine u du dx. The derivative of cosine of g of x, therefore minus sine g of x times g prime of x. So this one, of course, is a function of t. It doesn't matter. The way I approach it, as I mentioned in the beginning, is that I'm going to say cosine and I'm going to pause. The reason I do that, because now it tells me, okay, the derivative of cosine is negative sine. Then I look at this and I say, this is meaningless without an argument. It must have the same argument, and it does, 3 to the power 4. Finally, now I go with the chain rule and say, well, because this is not t, it's a function of t. The chain rule tells me I have to differentiate that, 12t cubed, and we put it in front, and y prime becomes negative 12t cubed sine of 3t to the power of 4 as the final answer. So a quick recap. Because it's cosine, the derivative is negative sine. Whatever the argument you have to use, because the argument is not just t or x or theta, but it's a function of t, you need its derivative. This is by the chain rule. Y equals e to the power of tan x. We want to differentiate it, and reminding everyone that the derivative of any exponential is itself when the base is e to the power of x. If it's e to the power of kx, e to the power of kx times k, e to the power of g of x, same thing times g prime. So the derivative of e to the power of tan x is itself times the derivative of tan x, which is secant squared x. And we're done. What about y equals 3 to the power of x? Now, we haven't dealt with a case where the base is not e. So what do we do? Well, let's generalize it. Y equals b to the power of x. And let's remind everybody of the following logarithmic properties. Ln of e to the power of x is x, e to the power of ln x is x. If that is the case, I can rewrite b according to this to e to the power of ln b. So I'm going to rewrite this following this. Therefore, it becomes e to the power of ln b to the power of x. According to the power rule, this is e times to the power of ln b times x. Bear in mind, ln b is a number. In essence, everybody, this is like k. It's just number, ln of b. So what is e to the power of kx? Itself times k. So itself times k. What is k? ln b. Now, we know e to the power of ln b to the power of x is b to the power of x. We put it in the same format. Therefore, y prime becomes b to the power of x times ln b. Very straightforward, everybody. So having said that, this says any exponential you start with the function itself. So the answer is 3 to the power of x. However, is the base e? No. So I need ln b. I need ln of 3. And now I'm going to rewrite it and I'm done. That's it. What about y equals 5 to the power of 30x squared? Well, the chain rule applies. In other words, If you have b to the power of f of x, the answer is itself. Then times ln b, because b is not e. This is by the logarithmic properties, times f prime of x by the chain rule. Therefore, the derivative is itself. You start with the function itself. The base is e, no, ln 5. Is the exponent x? No, it's a function of that by the chain rule 60x. And we rewrite it. Normally, we write the 60x ln 5 in front. And you don't want to put 60x after ln 5. One might think it's 5 times 60x. Not a good idea. Okay. So the final answer is 60x ln 5 times 5 to the power of 30x squared. F of x is x to the power of 4, e to the power of 2x. We want to differentiate that. We notice it's x to the power of 4 times e to the power of 2x. Therefore, f times g, and we use the product rule. So the answer is f prime g plus g prime f. So the derivative of this function is 4x cubed. This is h of x. That's f prime times g e to the power of 2x plus. Now, e to the power of 2x, if you want to differentiate that, it becomes itself times 2 and times x to the power of 4. We're done with calculus, but we are not finished with algebra. Therefore, we're going to look for common factors between 2 and 4. 2 is in common. X cubed and x to the power of 4. X cubed is in common. E to the power of 2x, of course, is in common. Therefore, 2x cubed e to the power of 2x. If you divide this one by this one, I hope you see that you get 2. If you divide this one by this one, you get x. So the final answer, same thing here, 2x cubed e to the power of 2x times the parentheses 2 plus x. This is the final answer, everybody. All right, what about this one? P of x is 9x times x minus 1 to the power of 4. Well, I'm going to throw in brackets and keep the 9 out. Remember, we discussed that this is one way to do it. Of course, 9 is not a huge number. It's not a large number. It's not a difficult number to deal with. You can keep it as part of x. But in any event, now f times g, and that makes this one f, this one g. To differentiate this, of course, we start with 9. So p prime of x is 9. F prime g plus g prime f. F prime is simply 1 times gx minus 1 to the power of 4 plus g prime. Now I'm going to use the extended power rule. 4 x minus 1 cubed times the derivative of the inside. Although it's 1, but I like to write it because I don't want to make a mistake. Now I'm done with that times f, which is x. And this is the end of calculus. Now we are going to simplify. So, of course, 9 remains, x minus 1 to the power of 4 or 3. Of course, x minus 1 cubed is the common factor, everybody. So if I divide this piece by this piece, I just get x minus 1. If I divide this piece by this piece, x minus 1 cubed goes away. I get 4 times 1 times x, or simply 4x. And now in the brackets, I can combine these two into 5x. The final answer, p prime of x becomes 9, x minus 1 cubed, 4 and 1, 5, 5x minus 1, and we are done. Now, y equals cosine to the power of 10 of sine x cubed. First, I want to rewrite this. I want everybody to see it's cosine of something, sine of x cubed, that is being raised to the power of 10. And in essence, never mind what this is. It's cosine of something to the power of 10. You need 10, cosine to the power of 9, and then the derivative of that. So I'm going to call this, because I want to make it easy for everybody to see what's happening. I'm going to call this f of x. Okay, we're going to come back to that. But for now, to differentiate that, I need, so y prime equals 10. Then this thing, whatever it is, this is the extended power rule we are using, everybody. If you go this route, it becomes really easy. So, as I mentioned, 10. Now this thing to the power of 9, so cosine to the power of 9 of f of x. Now, we need the derivative of f of x. In essence, if we go back to here, 10 cosine to the power of 9 and times the derivative of cosine, the derivative of the inside, minus sine f of x, the chain rule times f prime of x. Let's quickly recap. 10, same thing to the power of 9. Now you want to differentiate, let's see, differentiate this cosine, starting with just cosine, you get minus sine. Cosine minus sine. Minus sine of what? Same argument. What is the argument? F of x. The chain rule says times f prime. So now all we have to do, replace f of x with sine x cubed. So this is sine x cubed. This is sine x cubed. What is f prime of x? Now we are going to differentiate this. So let's write it. 10 cosine to the power of 9 of f of x is replaced by sine x cubed. Minus sine f of x is minus sine of x cubed. Now f prime of x, this piece. And bear in mind, this is f of x. What is the derivative of sine of x cubed with the sine? The answer is cosine. Cosine of what? Same thing, x cubed. You can't write the cosine without the argument. But the chain rule says, what is this? This is a function of x, so its derivative, which is 3x squared. And now we are done. We are going to put this all together in a proper order. Before I do that, before I show you the final answer, I'm going to recap. So cosine of f of x to the power of 10, you need 10. This thing to the power of 9. Then the derivative of cosine is negative sine. What is the argument? Whatever it is, f of x. Because it's a function of x, you need f prime of x. Then for the next step, we replace the f of x with sine of x cubed. And then f prime of x, we want to differentiate sine x cubed with the, which is cosine x cubed times 3x squared. I think this is the fastest and easiest way to approach it. Now, to put together, please understand these two become 30x squared. This negative sign makes it negative 30x squared times cosine of x cubed times cosine to the power of 9 of sine x cubed times sine of sine x cubed. Please bear in mind this negative sign has been accounted for here. So minus 30x squared cosine x cubed cosine to the power of 9 of sine x cubed sine of sine x cubed is the final answer. This is as interesting or as complicated as it gets.